Hello, good morning, good evening for some of us. My name is Ana Elena González Treviño. I am the director of the Center for Mexican Studies, UNAM-UK, and it is a great pleasure for me to welcome you today to this binational seminar between the University of Nottingham and the National Autonomous University of Mexico. Especially today, it is very appropriate to be holding this seminar in light of the recent launch of the rocket Artemis going back to the moon, which has made us very, very excited. It is also wonderful to consider the collaboration between UNAM and Nottingham University, who has been so instrumental for the development of aerospace engineering in Mexico and in UNAM. In that sense, we are welcoming all of you. First of all, I would like to receive on behalf of ENES-Juriquilla, which is the place where this course is going to be opening, Aurea Orozco, who is the General Secretary. Is she? Can you please turn on your camera, Aurea? And
yes, I have my camera on now. I don't know if you excellent. Can hear me. Yes.
Yes. Wonderful.
Okay.
If you wish to.
Well, I am here on behalf of Dr. Raúl Paredes, who's the director and who could not attend this meeting. And well, we are starting on this adventure of aeronautic engineering now with a new career that's going to be starting next August 2023. So this is, these are good times for UNAM and for our school, because we are going to be having students who are interested in this area, which is very thrilling and new to us. So thank you for having us here now.
Thank you very much, Aurea. And now I would like to give the mic to Shannon Baverstock on behalf of the University of Nottingham. Welcome, Shannon.
Thank you. Hi everyone, it's my pleasure to be here today. My name is Shannon Baverstock. I'm Senior Global Engagement Manager in the Global Engagement Strategy Support Unit at the University of Nottingham. So I'd like to begin by thanking Professor Ana Elena and Dr. Daphne for reaching out to us earlier this year to propose that the University of Nottingham join them in this initiative with UNAM. Thank you also to colleagues at UNAM and the University of Nottingham who have given their time to plan and contribute to this initiative throughout this year, today, and in the weeks ahead. Global engagement is at the core of who we are at the University of Nottingham, with overseas campuses in both China and Malaysia and partners in every corner of the globe. As a UON alumna, Daphne has highlighted that the University of Nottingham remains a global community far beyond the parameters of our campuses. This initiative links academics, researchers and students in both of our institutions and brings global engagement to a virtual space accessible to all. When we launched our Global Engagement Strategic Delivery Plan in 2020, little did we know the trials that lay ahead of us, but a truly positive outcome has been the virtual opportunities which have arisen as a result. We are here today to listen to talks on the subject of aerospace engineering, but we hope that this will be the start of university-wide collaboration and a variety of initiatives across all of our faculties. So thank you very much, and I hope everyone enjoys the presentations today. And I think without further ado, I will hand over to our first speaker. Our first speaker is from the University of Nottingham, Jez Turner. And Jez will be speaking on embedding space education into a foundation year. So over to you, Jez. Thank you.
Lovely. Thanks for all those introductions. And yes, I am really excited to be here. And
sorry, Jez, I'm really sorry to interrupt. I just received a message that Dr. Rafael Chavez is here from the High Technology Unit. I'm sorry, Dr. Chavez. Please, we're going to hear his welcome message and then over to you. I'm very sorry.
No problem at all. That's great.
Thank you. Well, first of all, I would like to greet Professor Jez and Professor Shannon from the University of Nottingham, as well as Dr. Anna from UNAM on the UK campus, and Dr. Daphne for organizing this seminar. My name is Rafael Chavez. I am a professor in the Department of Aerospace Engineering at the UNAM, and on behalf of the High Technology Unit of the Faculty of Engineering of the UNAM, I give you the warmest welcome to this binational seminar between the National Autonomous University of Mexico and the University of Nottingham. We know that the aerospace industry plays a vital role in the daily life of humanity. For that reason, at the UNAM, we are promoting the development of this industry in Mexico through different initiatives. Only to mention a few, we could talk about some nanosatellites projects, such as the QuauhtliSat project, the multi-institutional project named AztecSat Constellation, and the Kyoto project, which is expected to be launched next year. Through this type of initiative, it is so that the students have a complete experience in the development of the aerospace project. In specific, for the example mentioned above, we try to involve the students in the design of the missions, the development and construction of their subsystems, their integration and certification tests, the launch into orbit, and the operation of the satellite. In Mexico, the aerospace industry is no longer luxury, but a necessity. Therefore, it is necessary to have people trained in the area who participate in developing solutions for society and promote the country's technological development. We know of the University of Nottingham great experience in its aerospace department, so it is a great honor to participate with you in this event. I am sure this event will be of great value for academic training of the students of both universities. I am confident this will be just one of the many collaborations we will have between these great universities. Without further ado, I thank you again for the invitation, and I hope the seminar will be a great learning experience for all. Thank you.
Thank you. Thank you very much, Dr. Chavez. And now we are going to return to our first speaker. And just to the audience, I will let you know that the chat option will remain closed during the presentation, and it will open immediately afterwards, and where you will be able to either write your questions or raise your hand and turn on your camera and make them directly. Welcome, Jez. Please do go ahead with your presentation. Thank you.
No, that was lovely. That was well worthwhile listening to that. So I'd echo those sentiments as well. So it's absolutely lovely to hear that. Yes, aerospace engineering is at the heart of many of the things we do, and it can really enhance society. I totally agree with that. So here then, one thing, I'm going to start my presentation by just taking a little moment to think, and if hopefully you can see my screen by now, maybe if I can see a thumbs up or something, and that's
it's okay. It's okay. We can see.
Right. Lovely. Thank you. And I'd just like to think for a moment what this image perhaps even means to you, because to me it is inspirational. And this image here, if you don't know, is an image of the moon. And it's an image of the moon taken from the Apollo 8 astronauts in 1968. But we can see there the blue marble of Earth. And that really inspired me. And I think that's one of the things I want to get across in this image. It's why I'm passionate about foundation education that I'm involved in, is because I failed a lot of my high school exams. And that's because I had dyslexia. Well, I still do. And I didn't have any chance of getting into university, and it took me until 27 until I taught myself physics. And what inspired me was this image. This is one of the most important images for me. It exemplifies how fragile Earth is, and the birth of the environmental movement is cited to this image as well. So it's really exciting. But another thing that that really inspired me was these two things here, which is anyone who knows this, this is me sitting in Captain Kirk's chair, and Star Trek inspired me to learn physics, as well as a computer game. So computer gaming inspired me to learn physics. And I'm saying this because just grab onto your inspirations, and whatever they are, just keep trying. And if there's failures along the way, that's one of the important things we say in Foundation. You are likely to fail, and just inspiration cannot come any better than this morning. I had a little tear in my eye when SLS was launching this morning, and this echoes what we've just seen. There's Orion there on its translunar injection as it goes off to the moon. Orion this morning took a picture of Earth, so I think that's fantastic. So anyway, so what am I talking about here? And it's all about the inspiration and how we can use space engineering and use that in terms of module redesign. So we're going to talk a few things here, but I just want to introduce you firstly to what our course is, and whether you have similar ones as well. We can look at collaborating definitely on that, but our course, so Foundation Engineering and Physical Sciences, people can go after many different disciplines, and it's if they've taken the wrong qualifications or if they've had a challenging time to study. So I'd like to share that out there, because a lot of people don't know what Foundation engineering is, and it really isn't just like, oh, you've got to do this, so it's not, oh, you're not good enough. It's an opportunity for people to go out there and study some things, and there you can see our diverse team from across the planet really, who deliver the Foundation program. So if you have any questions about Foundation engineering, or any staff out there who want to collaborate on and see what we do in Foundation, please do get in touch with us. So one of the things you might be able to see behind me here, I've got this this rocket here, and the UK has, not many people realize this, as well as, and I'll come to this later, Mexico I've looked at, not many people realize what a rich heritage we have in terms of space flight. This rocket here, you see here, this one is off a rocket that the UK built, and the UK built that rocket with help, and this is where we have a dark history as well, with help from the V2 rocket, which this is an image of here. This is a turbo pump, and these are in just outside of Nottingham, Derby. And this rocket here, on the with me next to it, is the first stage of a rocket that was built in the 60s to launch UK satellites into orbit. And at the end of the Second World War, this dark history of rocket technology was taken from, Nazi scientists were taken from Germany, and a lot of them went to Coventry, about 40, about 100 went to Alabama, who built the moon missions. And Warner von Braun, in fact, eventually became head of NASA. But this history is built into the UK. So I'd just like to share that, because not many people know this. And Rolls-Royce, who eventually end up building these rockets, that's the Heritage Trust. You can actually go and have a look at these rockets in Derby, the local area to us. So that's interesting. And anyone who's ever heard of the Isle of Wight or has been there, there's actually a rocket test facility. And I did go around there and have a look in some of the restricted areas that you perhaps weren't meant to go. But this history is there waiting for you to discover. And we have a bright future. And in fact, a bright future together, hopefully with UNAM, we can work together on many different projects in the future. But that was the rocket they built, Black Arrow, and that launched rockets into space in the 60s, satellite into space in the 60s. So I use this as kind of inspiration, because now many people don't realize what opportunities there are in the UK to actually be involved in spaceflight and spaceflight engineering. And not only that, but people think about spaceflight in terms of astronauts going into space, but it's not just astronauts and engineers. We need reporters, we need artists, designers, business leaders, astrobiologists. We have an excellent astropharmacy and astromedicine department here at the University of Nottingham, where a team of PhD students, under the guidance of Phil, who is heading the astropharmacy department, have got a mission to the space station to look at different drugs and how different medicines work in space, because they work differently. So there's lots of opportunities to get involved in space and space flight. And if you've not seen this, any Nottingham students here, but it's worthwhile anyone looking at it. We have an excellent careers in space website as well for you to look at, and look at all these different opportunities you have to work in space. So with this passion, I've taken out this learning and done outreach at local schools, and we've brought students into the university. And you can see there, hopefully with this, you can see a whoosh bottle there with me doing an exciting experiment about rocket engineering. And there's a couple of my colleagues there, Tom and Francesco, and we've done outreach where we get students to come into university who would not ordinarily think about going to university. So we have those opportunities, and then we bring them into university, and it's really exciting, and they get here and they've seen all the things we've done with them in the past. And the thing is, another way that we really need to look at this is when the students get here, we need to make sure that they've got opportunities to see people from lots of different cultures. And that's one of the things that I've took, and all of these things build up to me having the opportunity to redesign a module. So if you've never seen this before, this is an amazing movie called Hidden Figures. And it was all about Catherine and her friends there, who were working behind the scenes, and there was no real recognition until much later on that these people were the mathematicians who solved the problem in getting astronauts to the moon back in the 60s. And in fact, that information that they worked out, the sort of free body problem, if you know what it is, in getting a spacecraft from one orbit to another with two gravitational bodies involved, was incredibly complex. And without them, the moon missions would not have happened. And I really passionately believe we need to get these things into the curriculum as well. So that's another reason for looking at redesigning curriculums with students. And thankfully, it was recognized, and there's Catherine getting a medal from Barack Obama there. And I think this is a real opportunity as well with UNAM and the University of Nottingham for us to look at each of our histories and perhaps bring some of those into each of our curriculums. And this gentleman here will definitely be coming into some of my lectures this year. Rodolfo, if you don't know, has close associations with UNAM and the University of Birmingham, where he did his PhD. But he's worked on satellite communications, and this I didn't know this. This was new to me. So this learning for me now, just having this opportunity to talk to you today has already enhanced the curriculum for people. And we're looking at people from lots of different cultures, and not just the stereotypical white middle-aged men like myself being the focus of the tension in the curriculum. So what did I do with all this information, this passion and this excitement? Well, people realized that I was quite excitable and enthusiastic. So they allowed me to kind of redesign a module. And this module that we had originally started off as a sort of a module that it got little bits and bobs, really important things that students need to know, foundation students need to know to get them onto year one. And what I actually did was I transferred all of this into this module. And I kind of made it into different parts. I kind of had the first part, which was all about experimental techniques, soldering, building amplification circuits and strain gauges. But how does that link in? Well, the first thing I did was, all right, well, these circuits here, Wheatstone bridges, are using sensing circuits, and they are scattered all across satellites, and we need to monitor them and during launches, during vibrational launches. So we looked at strain gauges as well, and amplifying signals, and we all looked at it in terms of space flight and vibration testing and all these sensors. And that's essentially what I did. I had this common theme of space and space flight. And I integrated it into the module. And then I took some of the ideas from here and I put them into here in terms of fluid pressure and fluid pressure measurements. And then that was linked to fluid dynamics. And you can hopefully see where this is going, because it ended up talking about these things here, rockets. So I ended up developing all the knowledge that they needed, but put it into a whole context of this thing here, which is a rocket. And this is a heritage Rolls-Royce rocket that they loaned me for outreach. And this was based on that Nazi technology, the V2 rockets. And I do love this, and the students love it when I take it out there. But we can have a look at this as part of the learning, and we can then actually have a look at the working parts of it, so we can understand what's going on, and hopefully that enhances the learning experience. But if anyone's interested, this is the start of the module, and this is essentially what I did. I got students, I get students to kind of build basic circuits, and then we move on to a bit of soldering, and then the next week we move on to a bit of amplification, and then they build these boards here. This is actually a student work, so these are directly student work, and we build this amplification board, and hopefully by doing it in a modular fashion, the students then realize what all of these components are doing here, these Wheatstone bridges and amplification circuits, and this thing here, the op amp. But then it's all right building this, but what are we going to do with it? Well, then we put a signal from these wires here, from this bar, which is, I've got 2 strain gauges on them, and we link it to all different areas. But in particular, I like to write exam questions based around the stresses and strains around maximum dynamic pressure. And we use an oscilloscope then to actually analyze this data. And then they have to write a lab report based on that. So it's all contextualized as well. And hopefully the students get a bit more excited about it. And so it really just integrating the space applications into assessment has engaged them so much more. So I've got some relatively good feedback from this module. And one of the key things that came out is, even though I do 4 weeks of practical work, there was still questions. It's Jez, we need more practical work in this. So what I did is I got a group of students then from a range of different backgrounds to come in with me. And I would strongly encourage any of you out there to really do this, engage in this process, which is speak to your lecturers, speak to your tutors, engage in the feedback to the tutors about the modules, and have a two-way process, because my students this year did an excellent job in looking at my resources and going, right, okay, well, I wish you'd have done this. This could have enhanced it a little bit. And sometimes I'll say, well, no, there's a reason I need to teach it that way. And other times they come up with fantastic ideas that I'd not thought of. So I've got our students involved in module redesign. And really the outcomes of that has been fantastic. It really has improved my teaching. So I'd recommend anyone out there to be able to really get involved in getting students into redesigning your modules with you. They have produced upgraded learning resources, and we worked on these together. I had objectives, but they were just on our learning platform, Moodle. They said, well, we'd actually like it if the objectives were on the notes you got, and we had a full section of equations for each week, rather than just the equations being scattered throughout the notes. They said it'll be a lot better if they were at the start and then repeated again later on. And they did some enhancements because of my dyslexia. They went, Jez, that's not spelt right. So that was really useful for me. And moving forward, I've got a group of students who are now going to be working on this and developing resources with me again. And this is something which has really just been really exciting for me. I've designed this, and you can see hopefully on the image there, this was my sort of prototype. And I was thinking I've got to do a lab with the Bernoulli equation and hopefully link it into rocket science. And students have given me feedback on this already. And I love this because here I invented this, and then I went to my colleagues and I said, well, can you build this and make it a bit more professional? And they did. And I love this. In our additive manufacturing, what we've done is we've had a prototype, We've had a second prototype, and then we've done part consolidation. We've taken 4 parts here and turned it into 1 part. I teach that to the students as well. This is what additive manufacturing is about and how it can help. So now, with student involvement, I've gone from animations, which are actually quite good and good for learning, and the previous year it was demonstrations, and next year with the students' help, now I've turned this into a laboratory that the students are going to do some investigations using simulated rocket science with air blowers and measuring pressure differences between areas, proving or not the Bernoulli principle. And we'll see how it goes, and I'll get feedback again. So I'd really recommend this. And all of this geekiness and excitedness has taken me further, because I've got some colleagues at the university who build satellites like this, CubeSats, and they've helped me. And we've actually now got in the foundation year an optional module for those students who want to get into the space industry. They're actually designing their own CubeSats as part of a project. And this is actual student work. They've used SolidWorks here to design a satellite and then do some stress testing on it. And that, for me, it's taken my knowledge even further, but it's so exciting. There is a link there. We've actually got the students themselves have been fantastic. They've created a guide to CubeSats as well. So if you have this presentation later on, and in fact, I'll skip that now. So if you have this presentation later on, you'll be able to find those links as well. So really, just in conclusion, to wrap things up, this module redesign myself with a space theme has really better prepared those students for year 1. They're totally engaged in the process, and they can see links to applications, not just in space, but in other areas. It's highlighted opportunities for them in the space industry, and the students are giving me really good feedback. And not only that, they've got opportunities to engage these students in the teaching and learning process. It's made my teaching better. It's also made the experience better for them. So overall, doing that outreach, like I said at the start, that inspiration, getting people into university is a great start. But the next steps really are to increase the number of PhD students and lecturers from underrepresented groups, and of doing that by creating more intriguing and inclusive educational opportunities is really something I'm passionate about, and hopefully we can work together with UNAM in the future. So on that note, I'll leave it there and say thank you very much. And if anyone does any questions now, that's fine, but you can always message me later, and I will stop sharing my screen if I remember how. There we go. Stop share.
Thank you so much, Jez. That was so interesting. I believe we're opening the chat box to questions now. So we have a hand raised. Manuel, if you'd like to switch on your camera and ask your question. I'm afraid we can't hear you.
What about now?
Yes, we can hear you now. Thank you.
Sorry, it was my headphones. First of all, Mr. Turner was a very interesting and inspirational presentation. Thank you for that. But my question is relation with the nozzle that you showed to us, that you have designed. I can see that it has 2 tubes in the lateral side. And I think that is because you're managing liquid propellant.
So the foundation year, we are these ones here. So in the foundation year, we are not doing full rocket science and rocket testing. What I'm using here is a simulated rocket, because our students need to have a reasonable understanding of fluid dynamics and hopefully the Bernoulli equation. And I link all that into the rocket equation. But here I've got an air blower with a manometer, so measuring pressure differences. And yeah, so it's simulating what it would be into, well, it is fluid. It's still a fluid, but it's air. And obviously the limitations with that, I think it's, yeah, sorry. Your question, does that help with phrasing your question? Oh, sorry, you're muted again.
Can we unmute Manuel, Angelica?
Oh, thank you. I couldn't reactivate my microphone. Yes, it answers. Thank you very much. I thought you were making the full rocket, but it is very interesting that modeling after the design of the nozzle. Thank you very much.
Okay, thanks.
So I think that's all the questions we have. I don't have any other hands up unless there are any in the chat box that I can't see.
Well, I would just like to make a comment, if possible, Shannon. Just how fantastic. I mean, teaching is so important, and it is very important to inspire and to awaken the enthusiasm of your students. And I believe that you have achieved this immensely. I come from a completely different background, but I want to go into this after listening to your presentation. So congratulations for that. I think all our audience will agree that you're inspiring both the students and the teachers, not to become better teachers, and to always be open to the feedback from students. You even speak of partnering with students, which I think is absolutely incredible, because then is when you are truly very inclusive and you are in the cutting edge of imaginative thinking, of creativity, of scientific creativity. So many congratulations for this, and I'm sure people may have to digest this a little bit, and maybe they will have some questions afterwards. But thank you very much for this, Jez.
No, that's the case. Thank you very much.
Jez, we have had one more question come up in the chat. So this is from Raoul, who says, hands-on learning is the best kind. I'm a biomedical engineer, and how hard would the jump to aerospace be?
Well, I mean, that is one of the key things, is what I was talking about at the start, where it's I started out as a mechanic, so fixing cars. And then I learned science on my own time. And then I did my degree in astronomy and planetary sciences at nighttime. Just online as well. Well, it was the birth of online learning. And I didn't get that much hands-on experience, but because I was passionate about it, I learned more about electronics, because then I found I needed to know more about electronics to understand how satellites worked, how sensors worked. And then that passion carries you forwards. It's hard. But as long as you're interested and you're passionate and you're willing to put the effort in and ask people and let them know when you're stuck and when you're in a mess, most importantly, and get people to help you out, then yeah, you can make that transition. I've done it from being a mechanic to being an astronomer to being now teaching engineering and rocket science. So I guess, and I'm quite dyslexic as well. I've had all those challenges along the way. So yeah, you can do it.
That's fantastic, Jez. Thank you. So I think that's the end of the questions for you, Jez. Thank you so much for talking today. It was very inspiring. I'm sure everyone will agree with that. And if we have any follow-up questions after the talk, I'm happy to take emails, as I'm sure Jez is as well. So I will hand over now to our next speaker. This is a speaker from UNAM, Dr. Jose Alberto Ramirez Aguilar, and he is part of the Galileo Information Center for Mexico, Central America, and the Caribbean. So over to you. Thank you.
Hello. Good afternoon, everyone. You can hear me?
Yes, we can hear you.
Okay, thank you. I'm going to talk about the space activities in our university. I want to start. 1 minute, please. Okay, you can see my presentation.
Yes, we can.
We can.
Okay, thank you. I'm going to turn off my camera to optimize the bandwidth. Okay, no problem. Okay. Good afternoon, everyone. Today I'm going to talk about some space project at National Autonomous University of Mexico. Of course, thank you very much for the invitation, and I hope we can collaborate on a space project between our university and the University of Nottingham. My name is Jose Alberto Ramirez Aguilar. Currently, I'm the head of the Aerospace department, and I'm going to talk about the UNAM Aerospace Engineering. I have a small agenda. For example, in the first space project at UNAM, Galileo Information Center, Project Galileo Consortiums, partners, expertise, roles and responsibilities, Project Galileo organizations, overview of the project plan, and conclusions. Space project at UNAM. Our country and our university have working on space technology. For example, in the 80s, our government bought 2 satellite systems, Morelos systems and Solidaridad systems. Another system called FEPS. The satellite systems were used for telecommunications, video, telephony, telemedicines, and among other applications, security, and other applications. Here, you can see some images of the Mexican satellites. Of course, for Mexico, what's a beautiful experience because Mexico has the first satellite for telecommunications. Of course, we in 16th and 17th, 18th years, Mexico has problems about the telecommunications and connections. And then the government started the project Morelos 1 and Morelos 2 and Solidaridad 1 and Solidaridad 2. Here we can see the primary control stations, alternate control station. Here, Mexico has 2 satellite control centers. One is located in Mexico City and the other in the north of country. And here we can see some of the orbital position of our satellites. Solidaridad 2, SatMex 5, another Mexican satellites, and SatMex 6, another Mexican satellite. Of course, it was a beautiful experience. We have big satellites. Now, of course, the technology was made in the USA. Next. In the 19th, the National Autonomous University of Mexico began space activities through the Space Research University program. Within the program, developed 2 microsatellites called UNAM-SAT-1 and UNAM-SAT-B. Of course, it was a good experience, or academic experience in space technology. In 1 microsatellite, of course, we had a little experience in space technology. The satellites, of course, helped to understand concept of orbital mechanics, space technology, tests, for example, vibration, for example, electromagnetic compatibility, for example, among another knowledge. UNAM-SAT-B, the microsatellites, it was the first satellite built in Mexico that had sent telemetry to Earth from the space in 1996. Of course, for Mexico, it was a hit because it was the first satellite built in Mexico. Of course, academic satellite. A scientific satellite, of course. Also in the 19th, another satellite project was started in which several higher education institutions collaborated. Of course, the microsatellite was not put into orbit due to various situations. For example, lack of financial resources, maybe a little experience in the space project, but of course, was a good experience in space technology in Mexico. Of course, in the National Autonomous University of Mexico. Currently, at UNAM, Unidad de Alta Tecnología or High Technology Unit, we continue working on several satellite projects. And here you can see some images of our laboratory, because we want to work in the space projects, because now is necessary to have several projects in space technology, satellites, of course, projects about in deep space, for example. It's very important to tell you that in 2018, our laboratory was accepted as a member of the International Astronautical Federation. It was an important fact to be able to continue working in space technology, because now we have facilities, we have a space project, we have specialists, Mexican specialists in space technology, and of course, the actual situation is very different now in our university. It's important to tell you that in 2003, we started a collaboration with the Russian Federation in the framework of the Condor satellite project. Of course, it was a beautiful experience, the language, the environment, the people, the cultures, and in the Russian Federation. But our group participated in the technical definition of the satellite, payload, and integration. Of course, it was a good experience working with the Russian colleagues, and we learned a lot about space technology. Of course, in the project, it was working to the University of Taiwan. It was a beautiful experience working with the other countries. This is the general scheme of the operation of the satellites, ground stations, antennas, receivers, high power amplifiers, low noise amplifiers, the satellite, and different organizations like Senapred, Conavio, and different institutions. Actually, we are also working on CANSAT's projects to work with students in space technology. We can see the several students, our students here in the National University of Mexico. For us, it's a good experience work in projects about CANSATs with the students. Currently, we are working on several projects and have always working with NASA to test subsystems of our nanosatellites. For example, CubeSats and TubeSats. You can see the some images in the test of the subsystem of our subsystem for the nanosatellites projects here in the National University. We can see some pictures from space. Of course, we are working with specialized software for simulations. You can see one example for our simulations. For our is very important to show to the students the simulations. For example, we have the software STK. It's a very good software for space applications, of course. We can see some pictures, a lot of students in the laboratory, in our facilities. Of course, we have several students, a lot of students, because they want to work in the space technology and satellites and rovers and CANSATs and different projects, space projects. We can see the good project. The mission is Kyoto. Tomorrow, Dr. Rafael Chavez will speak with more details about the project. We can see a lot of students in the laboratory, in the facilities. Now I will to tell you about the Galileo Information Centers. The Galileo Information Center is a collaborative project between UNAM and the European Commission. Our role in the project is the training of human resources in navigation system, especially with Galileo. Galileo is a European global navigation satellite systems, providing, of course, positioning and timing information with significant positive implication for many European service and users. Maybe in USA, in China, in Russia, in Mexico. See, we have several applications. We have several applications. For example, we have open services, search and rescue, high accuracy service. Application, for example, the Internet of Things, location-based on services, science, environment, weather, transport, automotive, for example, too, space application too, and civil engineering, and different applications. I want to show you a short video.
El posicionamiento a 23.000 kilómetros.
I'm so sorry.
Galileo es un sistema de precisión y fiabilidad.
Spanish.
Y a sus ciudadanos más preciso más. Con el
civilian controlled. EGNOS is EGNOS and Galileo app and a watch might have provided at am I? And what time is it? Simple questions really, and in the past, a map and a watch might have provided adequate answers. But times have changed. Today's world relies on the precision of global navigation satellite systems, or GNSS. EGNOS and Galileo pinpoint the location of people or objects and provide extremely accurate timing. First of all, let's look at what these two systems are. EGNOS is Europe's satellite augmentation system that makes GPS a lot more reliable and accurate in Europe. Galileo is Europe's independent, civilian-controlled global satellite navigation system. Now back to our two key questions. First, what time is it? Your watch or phone will do the trick not to be late for a meeting or dinner date. But phone networks need to precisely time data packets, power companies need to manage electricity sent over their network, and financial institutions timestamp transactions, timed to the millisecond. Galileo provides a timepiece that's accurate to around 10 billionths of a second, Galileo system time. Now for the second question. Where am I? We rely on GNSS for thousands of applications, and for many of these it's paramount for the location to be really precise and reliable. Galileo and EGNOS make navigation more accurate and reliable, which is convenient for navigating today and critical for tomorrow's technology like autonomous cars. The same is true for navigating large ships in ports with very little room to maneuver, and when emergency services need to respond quickly to distress calls. And there are many users outside the world of transport. Just think of a tractor applying fertilizer exactly where it's needed, land surveying, paying parking fees based on where you are, navigating in cities using your phone, mapping utilities, or finding your lost dog. EGNOS makes aviation safer, more efficient, cleaner, and less noisy by providing extremely reliable and accurate vertical guidance, so aircraft and helicopters can land more safely at smaller airports, even in bad weather. Millions of people, consumers, farmers, surveyors, and pilots already use EGNOS and Galileo today. And the European GNSS Agency aims to ensure we get the most out of EGNOS and Galileo by linking space to user needs.
Okay, it was a short video about the Galileo system. The Galileo Information Center for Mexico, Central America and the Caribbean is the information center on the technologies and programs of European global navigation satellite systems. Our university and we provide information, training and support to the satellite navigation industry in Mexico, Central America and the Caribbean. It's very important because, of course, here in Mexico, we have several sectors. For example, automotive, aeronautics, and now the space too. Of course, we need to reach new applications for example, in automotive, in aeronautic sectors. And then we want to show the capability of the Galileo system here in Mexico and in the United Mexican States and Central America, for example, in Costa Rica, El Salvador, Guatemala, Honduras, Panama, Haiti, and to the Caribbean, for example, Jamaica, Trinidad and Tobago, and Venezuela, for example. Of course, we need, we have new applications. Of course, we need to know more about the system GNSS in Mexico. Of course, there are several systems, for example, GPS and GLONASS, but we want to know more about the European system Galileo. Objectives, of course, is ensure and improve the visibility of the European satellite navigation activities in the region, and promote, of course, the cooperation of European and regional actors on different levels, and academics, industrial, and institutionals. It's very, very important for us. Develop knowledge of the local GNSS markets, monitoring local and regional satellite navigations initiatives to fully understand the specific characteristics and needs. Of course, the main coordination interface between Europe and the different Galileo information centers in Latin America. For example, we have two centers in America, for example, one in Brazil and another one in Chile. Now we are 3 centers of Galileo in Mexico, Chile, and Brazil. Of course, you can see the collaboration between institutionals and academic sector, industrial sector. Of course, European companies and Mexican companies and Brazilian companies and other sectors. Of course, we are an academic institutions. We are working in collaboration with the Universidad Politécnica de Madrid in Spain. We are 2 universities, UNAM and Universidad Politécnica de Madrid. We are working in the academic sector. We have a good collaboration in this project. Of course, there are several companies, for example, Telespacio Ibérica, Everis, Geotechnologies, INECO, and different companies. Of course, it's a beautiful experience, the project now. We have a website. You can see, you can find more information about the center. Of course, we need to know more about the technology in the space sector and the ground sector. But you can see more information. You can find more information about the project. In the project is working several companies, for example, Telespacio. They are leading companies with activities ranging from the design and development of the space system to the management of launch service and in-orbit satellite control, from Earth observation services, integrated communications, satellite navigation and localizations to scientific programs, for example. More information about the Telespacio, more information, and Geotechnologies, another company. It's a company founded in 1955 with the objective to providing services and products on geographic information system and global position system, for example. And more information about the company, responsibilities. Of course, the Universidad Politécnica de Madrid is the other university. Of course, they have several works. For example, generate a list of Galileo-related topics for theses at undergraduate and postgraduate levels, publishes an list of position for internship of students in industry, for example, implementation of a Galileo demonstrator, organize a student contest to promote the use of Galileo, for example, a hackathon to show new applications here in Latin America. Of course, our university has extension schools in the United States and Canada, of course, focusing on the Spanish language, English language, Mexican cultures. In the case of UNAM Canada, French language, of course. UNAM San Antonio, Texas, UNAM Los Angeles, California. Of course, our university has experience in design and implementation of antennas, for example, in microstrip technology for space and terrestrial application or ground segment, mainly for GNSS systems. Experience in the implementation of Earth station for reception of satellite signals in several frequency, very high frequency, ultra high frequency, L-band, S-band, X-band. For example, our participation in space research projects with application in space telecommunications, automotive, and aerospace, and close collaboration with the industrial sector, mainly in the electromagnetic compatibility test, for example, and development of satellite project with social application. Of course, we have several tasks. For example, cooperation between university from Mexico and Spain to provide high-level education, including PhD degree. We have the objective to generate a list of Galileo-related topics for thesis 2 at undergraduate and postgraduate levels. Of course, provision to courses and organization of training seminars in the fields of the GNSS technology and applications. For example, Galileo Classroom and Lab course in coordination with the Universidad Politécnica de Madrid. El Galileo System, el MOOC, el Massive Open Online Course, en Galileo Summer Camp in coordination with the Universidad Politécnica de Madrid. Y, of course, promotion and demonstration activities related to training and implementation of the Galileo demonstrator in coordination with the University of Madrid. Organize, of course, two student contests, hackathon to promote the use of Galileo in coordination with the Universidad Politécnica de Madrid. Of course, we have key personnel involved in the project. Dr. Rafael Chavez, he is the full-time professor, School of Engineering. Dr. Ferrer, full-time professor too, and Dr. Carlos Romo Fuentes, full-time professor too, School of Engineering, UNAM, here in Querétaro State. You can see several pictures about our facilities. Of course, currently we are working in several projects in space technology. Of course, we need more collaboration, for example, with your university, University of Nottingham. Of course, we know you has a good experience, a very hard experience in space technology. Of course, we need collaboration with other universities. You can see our country. You can see our state, Querétaro State, facilities, students, projects, satellites. And we have in the project with Galileo, we have a general project. Of course, work in markets and stakeholders in Mexico and the regions, promotion of European GNSS programs, facilitate the development of GNSS related applications, education and training on GNSS related, for example, industrial collaboration between Latin American and European partners. It's very important. Of course, we are working in the academic sector in collaboration with the National University of Madrid. Of course, we have a strong project consortium, local and European partners, industrial and academic levels, close to local and European institutions, clear project pacifications, means to overcome the pandemic constraints, coordination activities with other centers, for example, in Brazil, in Chile. Of course, the main objective is to show the system, the European system, the global navigation systems here in Latin America. This is the website, official website, Galileo OIC in Mexico. You can find more information. Thank you very much for your attention. That's all. Thank you very much. This is my email. This is my name. Thank you very much.
Thank you so much, Dr. Jose Alberto. Now we will take any questions. If anyone would like to raise their hand or leave a comment in the chat box.
Maybe no question, no comments.
So if anyone has any questions after the talk, you have email address in front of you there if you'd like to take it down. I think sometimes it takes some time to digest everything, and maybe those questions come up at a later time. So that concludes our talks today. So I will just hand back to Anna-Lena for our final comments, but just to say thank you very much everyone who attended today, and to our speakers. It was great to hear everyone's insights, and I'm looking forward to our following two events.
Perfect. Yes. Sí, muchísimas gracias, Dr. José Alberto Ramírez, and many thanks to Jez Turner as well, and to Shannon Bowerstock. Espero I hope this presentation has opened up the curiosity of what is being done on both sides, and that will continue to be, it will continue to be nourished in the following 2 sessions that we have. We have another one on the 23rd of November and the last one on the 30th of November. Tenemos 2 seminarios más, el 23 de noviembre y el 30 de noviembre. We really look forward to seeing you then. If you have any questions that come up later, you can always take note of them, and we will get them over to our speakers. Muchísimas gracias. Nos vemos en una semana para la siguiente presentación. Bravo.
Muchas gracias. Thank you very much.
Muchas gracias.